How's it going, guys? This is Ali, and welcome to Grade 12 Math for Dummies. Now, we're on Chapter 5, and this is do trig. And right now, I'm going to be teaching you about 5.5, which is making connections and instantaneous rate of change. So this is where the AROC and the IROC comes back into place. And we have a question over here, which I'm going to help you solve. And we're going to have to apply our knowledge for AROC, so average rate of change. Now, the speed at which Bob travels to work can be modeled by the function the distance equals 10 cos bracket pi over 15 t. So where t is time in minutes and d is the distance in kilometers. Now, the 10 over here would be the amplitude. As you can see, it's a cosine function, and the k value is pi over 15. Now, we don't have to worry that much about the cos and the 10, the amplitude, but we must take in the k into consideration for determining the period. Now, if you remember, period equals 2 pi divided by k. Now, it's 2 pi because 2 pi is the base period for both sine and cosine functions. So the k value basically either horizontally compresses or stretches the period, so it affects the period because it stretches or compresses the graph. In this case, it's going to be stretching the graph. P equals horizontally divided by, so k value is pi over 15 times 15 over pi. The pi's cancel out, cross multiplication, and 2 times 15 equals 30. Don't forget the p's. On the test, you might lose marks for this, communication error. Now the period that means is 30, and in the context of the question, it would be 30 minutes. So for one cycle to be complete, it takes 30 minutes. So it takes Bob 30 minutes to get to work, basically. And to calculate the average rate of change in which Bob is traveling, so this is question B, we're going to have to take into consideration this interval. So this is when 5 minutes goes by, and this is when 10 minutes go by. So we have the value for t. Now, if you remember the equation for finding out the AROC, so AROC equals d, so t2 plus d2 basically, and t1. So it's basically like the y2 minus x1 over x2 minus x1. So this is the AROC equation for finding out the average rate of change for this equation. Now we know the t values, which is 10 and 15, but we don't know the values for d, the distance. So what we're going to have to do is do some work on the side and figure out how much distance Bob has traveled when 10 minutes and 5 minutes have gone by. So let's do some work on the side. We're going to have to refer back to the equation we started with and basically plug in 10 and 5 into t. Let's start off with 10 cos bracket pi over 15 times 10. Now you should get -5 as your answer, and when we plug in 5 into the equation, so 10 cos should equal +5. Now we know the value for how much distance he has traveled. So we'll plug this into the equation, and so for this it's going to be -5 minus, now we have to put brackets here to remember, since this is positive, it doesn't really matter over here, but if the value of this number right here was a negative, it'll change the sign to a positive. So -5 minus 5 would be -10 over 5. We could reduce that to -2. So this is -2 kilometers per minute. So this just means that Bob is slowing down as at this point in the graph, and probably is where the coastline graph itself is decreasing. Now this is how you find out the AROC. Hopefully this was helpful, and good luck on your test. If you have any questions, please comment on the side, and thank you.